All right, here's a short example in class 14, rigid body velocity. Fairly simple one where we're taking Newt Dog and putting him on a bicycle, and we're going to take a look at a point, let's see, on the bicycle wheel that we're going to call A right here. Now, something we should know, if A were not slipping, the velocity of A would be 0 because it's touching the ground, and that point, it shares the same point as the ground, and as long as there's not sliding, that ground's not moving, therefore that point and instantaneously on the bicycle is actually 0 at that spot. So that's something to know. But it is slipping. We're told that it slips, and the bicycle is traveling at 3 feet per second, and the rear wheel is 26 inches in diameter. I once had that as the radius, and that would be a really big bicycle. And it's spinning at 4 radians per second. So let's draw our 3-diagram method right here. Here's the first wheel right here. There's the wheel. It's going to be equal to this other wheel plus another wheel right here, right? And so let me change colors, and green's a good one. We're told this velocity, we'll call this VC. And so we're going to, because we know that velocity, that's going to be the one that we use as our reference, and it's going to translate. And because that's the reference right there, that's also the one about which we're going to draw it pivoting right here. So I will draw a little ground joint right there, and so it's going to rotate about that. And we happen to know that it's rotating about this direction there of omega equals 4 radians per second. So we're trying to find the point A, which is down there. All right, so I don't quite know what direction exactly point A is going over right here. It's located right there. But over on here on the far right side, we know that it's moving this way, and here's the R, and that would be RA with respect to C right there. We know that if it's rotating that way, the velocity of A with respect to C is going to look that way. It's going to go in that direction. So you see what's going to happen here is that we're going to add VC together with VAC to find out what VA is going to be. So we wrote out the equation actually as this right here. VC is equal to, not equals, it's going to be plus VA with respect to C, all right? Just something a minor point to jump back here. Remember that that's like C right there. It's with respect to C with right there. So we use that C and that with respect to C to get A. So it kind of makes sense that it's written out that way. I think I've probably pointed that out before, but I'll point it out again. And if we were going to use vectors for this, right? If we're going to use vector math, what we would write out for the thing is going to, well, what we would want to know, we'd want to go that omega, let's see, is going to actually be, because it's clockwise, negative 4k right there, and we could say it's radians per second, and we did say that RA with respect to C, I don't know why it does that, is actually going to be negative, right? Because we're going A with respect to C, right? So it has to go, C is the ground point, so the vector is pointing downwards to there, so it's a negative 26 inches, and that's in the J direction right there, and that's going to be meters right there. So if we're going to write this out as vectors, we would say the velocity of A is equal to the velocity of C, which, by the way, we also need that velocity of C. We are told is going to be a positive 3I, and that's meter. Oh, well, I said meters, sorry. Okay, well, that's feet per second right there. So those are actually inches right here. We have to be careful with those units here in a minute. Yeah, so to set up the vector right here, we write out the vector equation, omega cross r a with respect to c, right there, right? And so that means that we're going to have 3i right there plus negative 4, and we're going to go, it's going to get multiplied by that negative 26, but let's turn those into feet right there. And then we want to have our k crossed with our j. And remember the right-hand rule here, right? Here's our I, J, and K right there. If we have a K crossed with J, so we move our hands and we put our, why is it, there you go. We'll notice that our thumb is going to point off in that direction. If we use the right-hand rule and we kind of rotate K into J with our fingers, we note that our thumb goes negative. So that means that K crossed into J is a negative I. Right there, right? So moving things together, we see that those are going to cancel each other out, but we do get a negative here at the end. So what we're left with here is that we're going to get a negative number. Right? If we take, so do I have my calculator up here? I think it's actually downstairs. That would have been foolish. I should bring my calculator up here. But let's take a look. What is 4 times 26 divided by 12? Should do this at home. 4 times 26 divided by 12. That's, and did I get the right thing? No, you know what? I made a mistake. I'm sorry. Let me fix this. You would have caught this on me, right? This is a diameter. So that's negative 13. Sorry about that. So that's negative 13 right there. All right. So that ends up being, right here, ends up being 4.333. So the answer ends up being negative 1.333 feet per second. And that's to be expected. It's going to be in that direction, right? So that's the answer. That's the direction that it goes. Now, in a 3-diagram method, instead, what we can do is we're still using the same equation up here, or we can even look at it down here. But usually we'll write out that equation, and then we'll write down in the x direction. We'll break it down in x direction and y direction. And here we notice that everything is in the x direction. If we didn't know that the thing was going to be in this direction, we would keep these as we would just keep them as positive. We'd assume positive if you didn't know. But here we might want to go and look at and decide ahead of time that, yeah, you could tell that's going to be negative. So when we write out the equation as a vector up above, but down here, as soon as we do the x direction, it's no longer, we only use the x components here. So I'll say that it's a negative VA, and I don't put a hat on there because I only need this VA right there. And on my diagram, it's negative, so I make it a negative here in the component breakdown. And then I add the VC to it right there, and you see that it's positive, right? And once again, we're focusing on that point A. That's what the equation is being written for. And then we see that the VA with respect to C, the relative, is actually in the negative direction. So it's negative. And we know that VAC is going to be omega AB. And we should say that's the absolute value, the magnitude, times R A with respect to C right there. So we go negative omega AB R A with respect to C. Have that set up, we can stick numbers inside there instead. Here we say that it's 3 and negative, and we know that we were supposed to take a 4 right there. We don't put a negative inside here because that's what this negative right here already was telling us, right? The one that we put in there based on observation of the diagram. And then R is going to be 13, but we know it's 13/12 right there. And we end up with a negative 1.333 feet per second. But we said that, hey, we have a negative. That means that we guessed correctly, right? So VAC as an answer is 1.333 feet per second. And let's give it an arrow right there. And that's our full answer. So there's two different methods to accomplish this. There's not really a vector triangle right here because we're really only dealing in everything. All the arrows are in the same plane or in the same sense, not necessarily the same direction. You can't really make a triangle that way. We'll see in the next problem, which is going to be much longer, how we address doing the vector triangle. So we do all three methods. I wouldn't ask you to do all three methods every time, but I do think you should be able to do all three. So that's the end of this one, and we'll do another example. Let's see, how short did this one end up being? Hey, it's at 11 minutes. That's pretty good. Wish all of them could be that long. So take care, guys.